squared and I'm dividing by 3x. That means 3x is in the denominator. This is straight out of the exponent law stuff. Yes, McKeon. Nice catch. All right. What's 9 divided by 3?
3.
What do you do with the exponents when you're dividing?
Minus them.
Subtract them, right? So x2 over x1 becomes x to the power of 1. So this is 3x. All right. With algebra tiles, I want to show you this just because. 9x squared divided by 3x. If we're doing it with algebra tiles, the numerator, the top, or the first bit, is what goes in here. This is 9x squared, right? There's 9 squares in there. We're dividing by 3x, which is this bit up here. I'm trying to figure out what goes in here. In other words, what do I multiply by this rectangle to get a full square? X. It has to be a rectangle, right? If you're looking at it from an algebra shape type of point of view. So if I have a rectangle there, rectangle and a rectangle will make a square. Rectangle, rectangle make a square. So what needs to be here?
Another rectangle.
And what needs to be here?
Another rectangle.
How many rectangles is that?
3.
There's your answer. Okay, so you're working backwards. I'm saying I've been given the answer essentially. I know what I'm dividing by. What did I multiply by to get this? It is in this case, but not all of them. But yes, in this case, it is a square root. Okay. Divide each pair. So we're going to go back to the algebra stuff. 6x squared divided by negative 2x. What's 6 divided by negative 2? Negative 3. X squared divided by x. Subtract the exponents and you get x. So the answer is negative 3x. 10xy divided by 5y. So 10 divided by 5.
10 divided by 5 is 2, and because the y is over 5 and 10 is xy, that means it's 2x.
There you go. So the y's cancel and you get 2x. Negative 12xy over negative 3xy. What's negative 12 divided by negative 3? What happens to the x's? And I'm left with a y. All right, can I flip the page? All right. Let's do these algebra ones first. So, negative 35 over 5. What's 35 divided by 5? 7. With a negative there, so it's negative 7. Is there any x's that can cancel? What about the next one? What cancels? X squared over x becomes just x, and there's nothing to simplify the 14. How does what? Sorry? Juniper. Because how many x's are at the top here? 2. All right. 37, or the next one, 34 divided by 7. Can you simplify that? nicely. Whole number. So nothing cancels. You just leave it. You're done. It's simplified. Or as they say, already reduced. 374. 55 divided by negative 11. Negative 5. That does not look like a 5. X squared over x becomes 4x squared z over xz. Does anything happen to the 4? What happens to the x squared and the x? Becomes 1x. And the z's? Bye-bye. Last one, 24 divided by negative 4.
Negative 6.
What happens to the y squareds?
Cancel each other out.
Boom. Z's?
Cancel each other out.
Boom. So it's just negative 6. Okay. Let's go back up here to the algebra tiles for 1 sec. Right here. So we're dividing 2x squared minus 20x by 2x. So remember this, essentially, that is all of this. This is the x squareds. There's 2 of them. And these are all x's. And there's 2 of them. There's negative 20. Why would we say negative? Why is there negative? Because they're shaded. All right. So we want to figure out. Oh, and I've got 2x, which is 2 rectangles. My answer is what's here. That's what I'm trying to figure out. Okay. So what would I have here to multiply by a rectangle to get a square? Another rectangle, right? Would it be positive or negative? Shaded or unshaded? Positive. It would be rectangle. And then you can see if I go rectangle times rectangle, I get square, rectangle times rectangle, I get square. What would I have here to multiply by a rectangle? Sorry, those are negative x's, right? Because they're shaded. So I'd have a tiny little square, shaded or unshaded? Shaded, right? And then I have one for every one of those rectangles, which gets a little tedious. And you see why they don't do this when they get into more complex and bigger numbers. So this is my answer. So what does 2x squared minus 20x over 2x equal? What does this rectangle represent? X. Not 10. They're shaded. Negative 10. So that means that 2x squared minus 20x divided by 2x is equal to x minus 10. Okay? We're going to learn how to do this algebraically in a bit. Maybe tomorrow. Okay, let's do this one. What does all this stuff here represent? The top, right? That. Negative 6x squared. There's negative x, negative x, negative x. 12 x's. 6 there, 6 there. Okay? They want to know. And we're dividing by negative 3x plus 6. So negative 3x is 3 rectangles. And the plus 6 is the little squares. Not shaded. This is my answer. So what am I going to put there? What would need to be here to multiply by this rectangle that is negative to get a negative square?
Positive rectangle.
A positive rectangle. So a rectangle that's not filled in. And right below it, same thing, positive rectangle. And then it matches because positive rectangle times little tiny square gives me a positive rectangle. So what's my answer? What's negative 6x squared plus 12x divided by negative 3x plus 6? Or it's positive 2x. Okay? All right. Here are your questions in the book. Not those ones. Ignore those. Page 255, numbers 10, 11, and 18a. Doing it with algebra tiles is 18a. Okay, so here's our x on the side. We have 2x plus 3 right here. Didn't I give you one?
I think that's pencil sharpener.
All right. If you take a rectangle times a rectangle. Come on, you two. Shh. What is, I take this rectangle, Magnus, and I multiply it by this rectangle. What do I get? You get a square. And then I do it again with these two rectangles.
Yes.
And then I take this rectangle and I multiply by this and I get a rectangle. And that happens 3 times.
Yes.
What is my answer? There you go. This is 2x squared plus 3x. Now, that is not the way we do it in Math 10 and above. The way we do it in Math 10 and above is we take this. Here's our question. And remember when we were collecting like terms and we were subtracting and I had questions like, I don't know, 3x plus 2 minus 2x plus 1. What'd you do with the negative? What did it do? What did the negative here do? It flipped all the signs because it got multiplied in. It was distributed in. That's what happens with this x. So you end up with x times 2x plus 3 times x. That x gets multiplied by everything inside the brackets. So what's x times 2x? 2x squared, because you are now adding the exponents. 3x is just 3x. And you get the same answer. Kidding? Okay, we're going to do it again. The one right below it, we'll do it algebraically first. Negative 3 any number that is outside of the brackets gets multiplied by everything inside the brackets. You don't have to show all the steps, but it would probably be helpful if you did it first. So negative 3 times 2x squared. Negative 3 times negative 2x. Guys, negative 3 times 1. That should be plus in there. Okay, what's negative 3 times 2? Negative 6. The x squared just stays the same because there's nothing to combine it with. plus negative 3 times negative 2. So that gives me 6x. Negative 3 times 1. Negative 3. So that is the answer. If you did it with algebra tiles, just to see that it would match, two x squareds, I can draw two squares up there. Negative 2x means, what do I do with the rectangles? Shade them. And then positive 1. Just a little box like that. Negative 3 is just they'll be shaded and they should be tiny little box squares. So there's negative 3, there's 2x squared, negative 2x plus 1. Okay. What is a little tiny shaded thing times a square? But what is a square? Has to be, and it has to be shaded, right? So I get a square that is shaded. And then I do it again. And then I do it with this one. And if I take this little tiny square that is shaded and I multiply it by a rectangle that is shaded, what do I get? Just a little rectangle. That is not shaded. And then the little tiny square times the non-shaded little tiny square gives me shaded square. And that happens 3 times. Which gives me 6. There's x squared, 6 of them, but they're all negative. There's 6 x's, and there's negative 3 little boxes. So you get the exact same thing. Okay, can I flip it? This is called the distributive property. Okay, because you're distributing that term that's on the outside to every term in the polynomial. So let's do these 3, and I'll give you a couple practice questions, and then we'll be done. So 5 times 4m plus 2. What do I do with the 5? By everything. So what's 5 times 4? 20. Does anything happen to the m? No. Then you multiply the 5 times the 2. That's it. If there's 3 terms, you do it to all 3 terms. Negative 3x times 5x squared. So what's negative 3 times 5? What's x? Remember, it's x to the power of 1 times x squared. What do you do with the exponents when you're multiplying the x's? So what's 1 plus 2? So that's negative 15x cubed. Then that negative 3x gets times by 4x. What's negative 3 times 4? What do I do with the x's? So I get x to the power of. And then finally, negative 3 times negative 5 is 15x. And the last question of the day, 8x times 2y minus 3x. So 8 times 2. X times y. Can you do anything with that? So we just write xy. 8 times negative 3. X times x. All right. Okay? All I want you to do is page 247, number 11, please.